Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi washabihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Allahumma la sahla illa ma ja'altahu sahla wa anta taj'al hazna idza syi'ta sahla. Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning. Okay guys, do you hear me?
Yes, doctor.
Okay, great. So, let's continue for the lecture 5, which is moment 3D. So let's recap back what you have learned last week. So it is regarding the moment, okay, moment in 3D. Okay, you have learned this equation last week, where m equal to r cross f. We are using cross product to solve to get the moment. Okay, so yeah, basically the thing that you should aware is we do have two different method. Okay, the first one is using this method, which is you have to identify the cross product, and then there is the second method, which is you can use determinant method, most simple than before. Okay, and then there is an example that you have learned last week, and you have learned about the shorter distance. Okay, you have learned on how to find the short distance using moment equation. Okay, so for today we are going to have this lecture, which is the scalar product. Okay, the dot product. Okay, so in moment 3D we do have two different product. The first one is cross product, which is you have to find the moment using cross product. And the second thing is the dot product, which is this is useful for three different kind of criteria, three different kind of solution. Okay, so dot product, of course you already know dot product is a scalar. The answer should be in not all, but some answer should be in scalar only. Okay, so I believe that you have learned this one during secondary or high school, where we do have a two vector, then we can dot it, we can make it a dot product for both vectors as shown in the slide. So let's say we do have a P and Q, and from P and Q we do have an angle theta there. Okay, so we can cross these two vectors using dot product, which is a P dot Q equal to P Q cos theta. Okay, and then if you want to Q dot P, the same solution will be given. Okay, which is PQ cosine theta, and then we note that we must know that the solution, the final solution of P dot Q is equal to Q dot P. It is not like cross product, which is P cross Q not similar to Q cross P, but in dot product PQ and QP will be similar answer, will be same answer. Okay, and the direction is not associated, so it is not applicable, it's not affected if you use dot product. Okay, so in dot product, there is the thing that you already know. Actually, you already know in mathematics. Okay, in mathematics, we just apply the mathematical foundation, fundamental to solve the static problem. Okay, in 3D analysis, vector are resolved into x, y, and z component. Okay, and we know that the cos theta, if we use the dot product, the cos theta must be equal either 1 or 0. Okay, this is the dot product. If you look at back the cross product, okay, if you look at back the cross product, Okay, we are using sine theta. Okay, we are using sine theta. Okay, this cross product, we are using sine theta. So the thing that we have to know, we do have two values of cross product, which is 0 or 1. And of course, sine theta is used for this cross product. But for the dot product, we use cos theta, okay, cosine theta. Okay, so if you look at this identity, okay, we can know that I dot I must be equal to 1. Okay, I dot I must be equal to 1, where the angle between P and Q, for example, P and Q must be same, okay, or 180, okay, 180 degree, okay. And the rest, if you look at the different component like I and J, okay, the answer should be 0 lah. Okay, different component IK, the answer is 0. So if you want to remember, just remember the same component will have a value of 1. The different component like J and I will have a 0 value. Okay, the only thing that have the value of 1 is the same component, which is II, JJ, and KK. This is the easiest way to remember for the dot product. Okay, so why we have to use dot product? So basically, the dot product is useful, okay, to determine this parameter, these three parameter. The first one is angle between two vectors. So we do have two vectors. Let's say the example that shown to you here. Okay, let's say we want to determine the angle between these two vectors. Then we have to use dot product. Okay, and then the second parameter is the moment of a force about an axis. And let's say we do have one force and we do have one axis like this, for example. Then we can determine a moment about this axis, okay, moment about this axis, okay. So this is the force, okay. So we can determine a moment about this axis using dot product. So later on, I will show you example. And the last one is the perpendicular. We can determine the perpendicular or 90 degree or nearest distance between two vectors in the line of action. Okay, so let's say we do have two vectors like this, okay, for example, okay, like this, and we want to determine the nearest distance, the perpendicular distance, the 90 degree distance between these two vectors. Okay, let's say the nearest distance is like this, for example, this, and this is the nearest distance, for example. Okay, so we can use dot product to determine this perpendicular distance. Okay, all right, so let's move to the next one. Okay, let's say you want to determine the angle between two vectors. Okay, so you have to use dot product. Okay, this is the example. Okay, we do have a P and Q there for the vectors, and we do have angle theta between two vectors. Okay, so as you know that P must be converted, must be in terms of IGK form. So we do have this formula, okay, this formula as well, okay. And then we do have the dot product to determine the theta there, where P dot Q equal to PQ cos theta. And then the formula here must be inserted into this formula dot product, okay. So finally, after rearrangement, you can get the theta there, okay, the theta, where P is the resultant, okay, P is the resultant, And of course, after rearrangement, you will get the theta, the final equation for theta. Okay, basically, for me, I don't want to remember this formula. Okay, I don't want to remember this formula. Basically, I will use this formula. P dot Q equal to P Q cos theta. Then I will derive it from here to get the theta. Okay, this is my method. You can, it's up to you. If you want to remember this formula, cos theta equal to xq plus pyq plus pzqz, okay, over pq, then it's up to you. It's up to you. So my method, I only remember this thing, then I can derive from here to get the theta. Okay, so this is the example. Okay, so this is the example. Okay, let's say we do have two vectors here. For example, I put it, it is from origin lah, origin. So let's say I draw it like this. Okay, let's say I draw it like this. This is the axis. This is your vector. Let's say this is the vector of P. We have 6. Let's start from origin. For example, I put it origin. 6. This one is 6. 6 here. And then the back one is 7, -7. Let's say here. Okay, -7. So your vector should be like this lah. From here to here. This is your P. Okay. And then for the Q, okay, Q we do have -6 here, for example, plus 33, for example, plus 33 is here lah. Okay, and then minus 30 should be far away from the origin, like here, for example. So your Q is, sorry, let me repeat. Okay, your Q, I put it this color. Okay, should be like this from here to here. Okay, let's say I put it, the vectors coming from origin, for example. This is an only example. Okay, I put it to make you understand where is the theta belongs. Okay, so basically the theta should be from P to Q like this. This is your theta. Okay. Oops. So this is the thing that you have to imagine. Okay, where is P, where is Q based on the question. Then you can understand where is the theta. Okay. All right. This example showing you on how to solve the theta, on how to get the theta. Okay, you have to determine the angle between vectors P and Q. So if I put it into illustration, the theta will be shown like this. Okay, we have to find the theta there. So basically what you have to is, you have to use dot product. Okay, because the theta value is in scalar. Theta value in scalar product. So you have to use dot product. Okay, so basically you do have this equation. Okay, where cos theta equal to PQ over PQ. Okay, all right. So you have to substitute all the values that are available from the question into the equation. Okay, we do have the value of PQ, yeah, PX, okay, PY, PZ. Okay, Oops. Then we do have a QX, QY, and QZ. Okay. Okay. Then from here, you can determine the resultant of P and Q. Then we get the resultant. And then you substitute all those information into the equation. Okay, you will get the answer. Okay, this substitute all information there, you will get the final answer of theta. Okay, this is the answer for this one, and then substitute into this one. Okay, this one into this one, you will get the answer of theta, and the final answer is 41.3538. Okay, and then we can illustrate that the theta here is 41.38 degrees. Okay, so easy, right? Just mathematics, just a mathematics. Substitute here, substitute there, then you get the final answer. Okay, any questions so far? Is there any question?
Doctor.
No? Can we proceed? Ada orang ke tak ada ni?
Yeah, can Doctor, we can proceed.
Okay, okay. Alright. Tak syok lah ajar online kan. Tak ada respon. Okay, so let's proceed to the next slide, which is a moment of force about an axis. So if you want to determine a moment of force about an axis, okay, you have to use dot product. Okay, about an axis and about a point is different. Okay, so last week you have learned a moment about a point. This one. Oops. Okay, this one, right hand rule and using cross product. So this is the moment about a point using cross product. But today, you will learn on how to determine a moment of force about an axis. Okay, so basically we will use dot product. Okay, and of course the moment about a point should be in cross product. This one is cross product, should be cross. Okay, and then the thing that you have to find is moment about an axis should be dot product between lambda axis and moment of force about a point. Okay, this is the definition of a moment of a force about an axis. The equation is m axis equal to lambda axis dot m point. Okay, and we know that this, we do have this equation r cross f. Okay, so since r here, okay, since r here, we have at least two different values. Okay, at least two different values. Okay, so in this case, because it is an axis, okay, at the end of the day, you will have four different r. Okay, four different r, because for example, like this, because n axis we do have two different point, okay, two different point, like not like a point there last time. Let me choose another color. Let's say this is the axis, okay, the axis point A and point B, for example, okay. So your force, let's say from here to here, this is your force, and we know that R can have two different R, okay. The first R here, second R, the third R, and fourth R, okay. So in this case, about an axis, we do have four different R, okay. And then of course, you have to use the simplest R to avoid confusing, of course, and then to minimize errors, and then to speed up your calculation, okay. So you have to use the simplest R to determine the moment, okay. So we will go further in the example later. Okay, so this equation, okay, as I mentioned to you, this moment have two, so each moment have different R. Let's say this one, like I draw it here, okay, R3 and R4, okay. Okay, you can use either one, but my suggestion is that you have to use simplest R, okay. So the equation, we know that the equation ma is a moment of force about an axis, of course, okay, this one. Let's say AB is the axis, lambda AB is the unit vector from A to B. From A to B, the unit vector must be in terms of IJK form, yeah. And then MA or MB is a moment of force about a point or point, okay. We do have two different points as I shown in the slide, okay. All right, so far so good.
Doctor.
Okay, so let's proceed to the example, then you can know what is the moment of force about an axis, okay. So this example is actually extension from previous example, okay. Let me recap back the previous example, okay. This is the previous example, example 1, okay. So example 3 just now is we have another point which is B here, okay. So it is an extension from here. Example 3, example 3. Okay, yeah, example 3 here. So basically it is similar in terms of F, but the difference is only for the R, okay. Let's we proceed to the example. So from this example, you have to determine the moment of force 3000 Newton about the axis AB. We do have an axis AB there, dot line there from A to B, okay. All right, so of course we do have F from C to D, okay. So how to determine? You have to use this formula lambda axis dot M, okay. Dot M should be A or MB, okay. So let's see the solution. So we do have this definition, M axis equal to lambda axis dot M point, and then you can have two different moment of a point, okay. either MA or MB, okay, the lambda AB will be similar because we do have only one as is there, AB. Okay, the different thing is a moment A and moment B. Okay, from moment A, as I said just now, we do have two different R. Okay, the first R is RAC. Okay, from A, which from A to C, RAC. The second R is from A to D. Yeah, RAD, RAD. Okay, so we do have RAC and RAD. Okay, and the rest is similar. FCD, lambda AB is same. Okay, and for the MB, again we do have two different R. Okay, from here B, two different R. The first one is RBC, from here to here. RBC. The second one is from B to D. Here, RBD. Okay, sorry. So we have RBC and RBD, different one. Okay, and of course the rest like lambda E, FCD, lambda AB, and FCD is same for all. Okay, so the first thing that you have to do to determine this moment is actually you have to identify the R first. Okay, you have to identify the R first. Okay, all right, so if you look at the sentence there, observe that lambda AB and FCD are common to all equation. As I said, it is same to all equation. Okay, the difference lies in the position vector, which is R. Okay, the R is only the thing that different. Unless otherwise stated, it is advisable to choose the simplest R. So as I said just now, you have to choose the simplest R to determine the moment. Okay, so the first thing you have to do is to determine R first. Okay, so R. Okay, before I proceed, maybe it is just a simple question from you. Okay, can you say to me what is the value for RAC? Someone, please. RAC, someone, please.
Three, is it three?
Huh?
Is it three?
No. It is must be in terms of IGK form. In 3D, this is 3D. Yes, correct. Same B key. The answer is 2J plus 1.2K. Don't refer the lecture note first. I want to test you. I want to have two-ways communication. All right. So the first R is RAC. Okay, you can get how much? 2G plus 1.2K. This is your RAC. RAC 1.2. Okay, how about RAD? Oops. How about RAD? How much RAD? From A to D. Guys. Diva Sen, Diva, are you here with me? Diva Sen. Dengar ke tak dengar? Ilya Kasrina. What is your answer for RAD? From A to D. Ada tak Ilya ni? Hidup lagi tak? Tak ada orang Ilya. Okay, cepatlah balik UTM senang sikit nak kelas. So RAD should be from A to D. So we do have negative 0.4 I. Okay, and then the Z component 1.2 plus 2.2, which is 3.4 lah. Okay, this is RAD. Okay, how about BC. RBC. Can someone tell me? Okay, I call a name. Faris. RBC.
Sekejap, lagi sekejap.
Okay.
2.4i plus 4.4j.
Sorry?
2.4i plus 4.4j.
Okay, the answer is negative 2.4. Negative, right? Betul tak Faris? Negatif.
Why negative?
Minus 2.4, is it? Betul tak?
Tak tahu. Kenapa negatif?
Kenapa negatif? Wait, give me 1 second. Okay, so anyone got answer? Anyone can answer why we get negative 2.4?
Because of direction BC to the left.
Yes, correct. Because of the direction from B to C. Okay, from B to C. Make sure that the direction is correct. The method is correct just now, Faris, but the direction is wrong. So direction from B to C here. Okay, D is negative 2.4. Okay, and the direction for what do you call it? K. K. Sorry, it's not K. J. Sorry, this one is J. This one is J. Sorry. This one is J. Tak keluar. Give me 1 second. Can you see the screen right now?
Betul.
I hear something, but it's not appear in the screen, on the screen. G. Maybe the internet connection. Can you see the screen? The line, the orange line. Can?
No, doctor.
No. Wait, give me 1 second. I think the internet. The problem is the internet. Let me solve this problem. Okay. Macam mana nak buat ni? Oh. Okay, give me 1 second. Still not there. Let me check the internet connection. Wait, give me 1 second. Okay, how about this? You can see it, is it?
Yes, doctor.
Okay, great. So the thing that I just show you is the line, the orange line there. Okay, from B to C here, from B to C. Okay, the magnitude is 2.4, but the direction is negative because it is coming from right to left. Okay, coming from right to left. Okay, and then the J component, Y component. Okay, 4.4 lah. Okay, we do have 2.4 here plus plus 2 here 2, so 2 plus 2.4 we get 4.4J. Okay, the last one RBD. How much RBD? If someone tell me, okay, I will call a name. The lucky one is Sharifah Raihana. RBD, please. Sharifah, what is the answer for RBD? RBD. Oh, RBD.
Doctor, can I try?
Wait a moment. I give to Sharifah first.
Okay, doctor.
Yeah. Sharifah, the answer please. Sharifah ada ke ni? Ke tak ada? Please respond. Sharifah Raihana, are you here? Tak ada Serius
Sorry, doctor. Yes, I'm here.
Okay, good. So I'm waiting for the answer.
The answer is 2.4G.
G.
2.4G.
Okay,
Two-
then
negative 2.8x and 2.2k.
okay, yes. X should be I lah. Okay, X
Oh,
should
okay.
be I. So the answer is correct. The answer is correct. It should be a negative 2.8 I plus 2.4 G plus 2.2 K.
Okay.
Okay, right. So this is the answer for R, all R's. Okay, RAC, RAD, RBC, RBD. Okay, so again, you have to use the simplest R. Okay, so in this case, which one is the simplest one? Someone?
RAC, Doctor.
Yes. For me, I will choose RAC because RAC, both of components is in positive direction. Okay, we can reduce our mistake for the further calculation later on. Okay, the rest, RAD, RBC is still simplest, but RAD and RBC have the negative value. So maybe in the future, in the further calculation, we will make mistake because of the direction. So I prefer, in this case, I prefer to use RAC. Okay, the simplest one, you should choose the less component. I mean, the simplest is having a less number of components. Okay, for RBD, we do have 3 component. Oops. So we are okay. RBD here, we do have 3 component S, Y, Z, which is different for the next calculation. So the simplest one is these 3. And another simplest one is this positive value. Okay. So for my case, for my opinion, for me, I will use RAC. Okay. All right. So when you have the value of R, okay, you can proceed to the next one, which is the first one you can determine MA lah. If you are using RAC, then you have to determine MA. Okay, here, because we are using RAC. Okay, and of course, MA, we have this equation, RAC cross FCD. So FCD, you have to convert it into IJK form. Okay, so it is shown in the previous example 1. Okay, we just proceed with the solution there. So this is the FCD. Okay, using coordinate system, you have to find the x, dy, dz, and d, and then substitute all those information into the equation. Then you will get FCD. Okay, and then the lambda. Okay, this one is having, you have a moment later on. Okay, and then a lambda exists, which is lambda a, sorry, lambda ab. Okay, lambda ab. So it is a unit vector from A to B. It is similar like coordinate system, coordinate method. You have to determine dx, dy, dz, and d. Okay, from this case, okay, we have a dx. Dx is this one. Okay, positive dx. Okay, and dy, we have this one, dy. Okay, and dz, we have this one. This dy should be negative, right? Okay, oops. And dz is 1.2, which is positive. This is the dz positive. Okay, do you get on how I determine positive and negative?
Yes.
Okay, easy, right? It is only direction. Okay. So you have this information, ds, dy, dz, insert into the equation here, and then you will get the lambda ab in terms of IJK form. Okay. All right. So substitute lambda and substitute moment A, okay, into the equation, and substitute R, the simplest R, RAC into the equation, then you have to solve, you have to simplify, and you will get the answer for the moment about an axis, a moment of force about an axis. Okay, so this is the lambda AB. Okay, this is ROC, RAC, sorry, this is the FCD. So you have to cross these two, R and F, then you have to dot it with lambda axis, okay, and then you will get the final answer. The rest is mathematics. The rest is mathematics. I will not show you. I will not explain further. Okay, the rest is mathematics. Okay. So far, so good. Okay, in this lecture, I will show the solution without practicing. Okay, we only practice on how to determine R just now. And the letter exercise example, you have to practice lah. Okay, to practice. Okay, is there any question before we proceed? Is there any question?
Doctor,
Yeah.
I get the overall idea, but I want to know something. How to
Yes.
know FCD or which R, like RAC, or for the vector? How to know? How to know AC or AD or which one to choose?
Okay, great question. Great question. Okay, the first thing that I said just now, you have to use the simplest R. Okay, no matter R that you use, the answer will be same. But to reduce errors during the calculation, okay, to speed up the calculation process, you have to use the simplest R. Okay, in this case, the simplest R that we have determined just now is RAC. Okay, in the calculation, you can use RAD, RBC, or RBD. Okay, but it will give more time. You have to spend more time to get the answer. Okay, and maybe there are some errors that occur during the calculation. That's why we have to use the simplest R. Okay, so if you substitute RAD, RBC, RBD into the equation, okay, you will get the same answer actually. You can try it. Okay, you can try it later. So if you use, instead of RAC, you use RAD, RBC, RBD, okay, the same answer, you will get the same answer. 5,120 Newton meter, you will get the same answer. Okay, you have to try, you have to try. Okay, in this class, I will not show you because we not have enough time to show everything. Okay, Osam?
Yes, doctor. Okay. Thank you, doctor.
All right. So FCD is very straightforward because we do have one F in this system from C to D, F. So it is same to all calculation. Same goes to lambda AB. Lambda AB is very fixed. So we do have one value of lambda AB, but R, we have 4. R, okay, for R. Okay. Okay, never mind. We do have exercise after this. We can discuss the exercise together. Is there any more question before I proceed to the next one? Is there any more question? No. Okay. Okay, let's proceed to the next one. Okay, the next one is regarding the nearest distance. Okay, the nearest distance between two vectors. Okay, if you have two vectors, different vectors, okay, like in 2D, you can get the nearest distance. Okay, nearest distance. Okay, okay, this is different with nearest distance between point and force. Okay, the last week, we learned about the nearest distance as well, but it is from point to the force. Okay, like this. Okay, this is the example what we have covered last week. This is the line of action. Okay, and this is the point A. Okay, the nearest distance from point A to CD, like this, for example, must be perpendicular. Okay, for example, it must be perpendicular. This is the D. Okay, it is not similar like the nearest distance from the axis to the line of action. Okay, this is the nearest distance from point to the line of action. Okay, from here we can use the 2D equation, which is this one. Okay, which is this one. We can use 2D equation to determine the nearest distance, the shortest distance. Okay, the 90-degree distance. Okay, using 2D formula. But for today, for this one, okay, it is a nearest distance between two vectors. Okay, let's say we do have let's say this is only example, example only. This is only example. So we do have a vectors, one vector like this, for example, P, for example. Okay, and another vector maybe like this lah, for example, Q. Okay, so the nearest distance is from the line of action to the line of action, like this. For example, I put the line of action, line of distance like this, for example, yeah. Oops. Give me 1 second. Alamak. Alamak, tak boleh padam. Okay. Just continue. Okay, this is the distance, for example, D, but the line should be perpendicular to each line of action, like this, for example. Okay. Okay, this is the thing that we learn today. We learn now. Last week, we learned the nearest distance between point to the line of action. And this time, we learn the nearest distance between two vectors from P to Q, from Q to P, the nearest distance. Okay, okay, so, sorry. So the component, okay, of a vector that is parallel to an axis AB is given. Let's say we do have a axis, okay, an axis, okay, an axis. It's not like similar that I show you right now. Let me erase all the ink, okay. So let's say we do have an axis, okay. Axis can be in terms of vector as well because we do have IJK form, okay. Let's say we do have an axis and also we do have one force. So we can find one distance, nearest distance from the force to the axis. Okay, the axis should be vector as well, vector product. Okay, the force should be vector product as well. So we can find this distance from axis to the force. Okay, so the first thing that we have to know is the equation. Okay, the component of a vector phi f that is parallel to an axis AB is given by this equation. Okay, so we do have f parallel. Okay, we do have f. We do have f parallel equal to lambda AB dot f. Okay, dot f. And then we do have another equation. Okay, this is the theorem Pythagoras equation. okay, we can get it f perpendicular equal to square root f power of 2 minus f parallel power of 2. So this equation is coming from the Pythagoras theorem. Perpendicular power of 2 plus f parallel power of 2. Okay. So this equation from the Pythagoras theorem. Okay. So from the definition of moment about an axis, okay, still use the 2D equation, okay, because the scalar product, we have to get the scalar product, D is scalar product, okay. So we have to use this equation from 2D moment, okay. M equal to FD, so F should be perpendicular. So F should be perpendicular because we want to find the D perpendicular, meaning that F must be perpendicular as well. Okay, this D is perpendicular. And then F must be perpendicular as well. So we do have M axis equal to F perpendicular times with D perpendicular as well. So rearrange back, you will get this final equation for the nearest distance between two vectors of M axis, between the axis and F. Okay, so D equal to M axis over F perpendicular. Okay, so basically the first thing that you have to determine the D, the nearest distance, the first thing you have to determine M axis lah, as shown in the previous example. Okay, and then you have to determine F perpendicular using this equation. Okay, all right. Okay, if okay, then we proceed to example 4. Okay, example 4 is actually an extension from example 3. Okay, the only thing that we have to calculate in this example is the shortest distance. Okay, we have to find the shortest distance. Okay, from the previous example, we do have the M axis. Okay, M axis, sorry, this one, example 3. Okay, we do have M axis, which is the value is 5,120 Newton meter. Okay. So you have to use this formula. Yes, this D equal to M axis over F perpendicular. So in this solution, example 4, we just apply this equation because example 3 already give the value of M axis. Okay. So let's see the solution. Okay, the idea is that you have to find M, of course, already got it from the previous example. And then you have to find F perpendicular using this equation, okay? And then you have to find F parallel using this equation, okay? Once you have the perpendicular distance, perpendicular force, then you can substitute into this equation, okay? All right. And the equation for the F parallel is equal to lambda AB. So lambda AB already known from the previous example as well. Okay, and F already known from the previous example. Just substitute into the equation of F parallel, then you will get the value of F parallel in scalar product. Okay, in scalar product. Okay, in scalar product. Okay, then since the equation of F perpendicular should be there, you have to substitute this value into the equation, the theorem Pythagoras equation there. Okay, then you will get the F perpendicular. And then finally, substitute M axis into the equation, you will get straightforward the answer for the nearest distance between two vectors. Okay. The rest is mathematics. The only thing for the static is these two. These two. Okay, if you want to illustrate where is the nearest distance, okay, I can just imagine. You can just imagine where is the nearest, the shorter distance between two vectors. Okay, let's say the nearest should be like this lah. For example, this is only example. Okay, we cannot see in 2D. We cannot see in the screen. We have to use software to know where is the nearest. But the idea is that it is from the axis to the line of force. Let's say the nearest distance, for example, here. This is the nearest distance, for example, and the angle should be perpendicular like this, 90 degree. This is the D, for example. It is not fixed like I draw here. Okay, maybe the D, if you draw the line of action here, okay, the line of axis like this, maybe the D like this, for example. Now we cannot see on the screen because screen is 2D. We have to use software to get the information, to illustrate, to imagine where is the D belongs. Okay, so the idea is like that. Okay, are you okay? Guys, are you okay? No?
Yes, doctor.
Yes, doctor.
Oh, okay, okay. All right. So if okay, then let's do this exercise together. Okay. Before we end the class, this exercise. Okay, this is the moment actually, moment about an axis. A moment of force about an axis. Okay. So the idea is that you have to find a moment of a force 150 Newton about the diagonal BA. Okay, diagonal BA. So we do have this axis actually, BA axis. Okay, and the force is located at here. Okay, and then the question, you have to find moment lah. So the question not mention a moment about an axis. The question not mention about moment of a force about a point. Okay, but the question only state about the diagonal BA. So if you read through diagonal BA, it is a axis actually from B to A. Okay, from B to A. So you have to use a scalar product to get the moment about the axis, about an axis. Okay, so okay, let's start together. Let's start together. What is the first thing that you have to do? Can someone tell me what is the first thing? Saint Vicky. Okay. What we should do first?
Find the R.
Yes, correct. Find the R. Yes. Where is the R actually? Again, Saint Vicky, I ask you. Where is the R? From where to where?
From A to F or B to F. Is it like that?
Yes, correct. But F, where F? Because we do have 2 points there. Okay. So everyone you have to think as well, not only C, B, K. Putri Irina.
Yes, Doctor.
Yeah. My question is, where is the R? Where to where?
I don't know, Doctor.
Okay. Great answer actually. Nick Muhammad Azri. Nick Muhammad Azri, where is the R? Where is the love? Where is the R? Mana R?
Where?
Hah? Tak dengar.
Don't know.
Don't know. R. Okay. I put it. R is don't know. Okay, correct. Betul-betul lah. Nick Muhammad Azri, where is the R?
BC?
Okay. Let recap back. Let recap back what you have learned just now from the previous exercise. From previous exercise. So if you look at this exercise, okay, this one that I counting yeah. So the R is from the point of axis, any point from the axis to the force, okay. From this exercise, we do have RAC from A to C, okay, and then from A to D, RAD, and then another point of the axis, B to C, and then B to D, okay. All right. So the R should be from axis to the force, okay, from axis to the force, okay. So if you look at this exercise, okay, it should be from the axis to the force. Then where is the R? Where is the R? Where is the R? Where is the R? Okay, I call a name again. Ikmal Danish. Muhammad Ikmal Danish. Where is the R?
Kata AC, AB, BC to B tu pasti. Betul ke? Betul.
No, the answer is wrong. From axis to force. AC is not force. C is not force.
Force.
C is not a line of force.
Yang tanda arrow tu ke yang force doctor? Tengah-tengah.
Yeah. The force is the arrow.
So A ke F tu lah. A, F, B, F.
Yeah, F, we do have two different points, the initial point and the final point. So we have to choose which point.
Doctor, is it the tengah-tengah tu?
Yes. Simbiki, yes, tengah-tengah. The middle one, not really middle because it's not, not middle. But in this case, the force only have 1 point given. Okay, it is not similar like the example 3. Example 3, the force CD, okay, we do have 2 points. The first point is C, okay. The second point is D, okay, for the force. But the exercise 1, there is only 1 point at the force that given from the question. The point is here. We do have only 1 point at the force. This one is not given. This one is not given. So we cannot use this point to have R, to get R. Okay, so the end point of force is not given. It's not given. But the point here, the first point here, for example, I put it A, B, C, D lah. I put it here D. Okay, the point D is given. You can determine the D there. Okay. Okay, again, my question, where is the R? from one point to another point, right? So from where to where, R? Maria Alessandra from Philippines, yeah. Do you have any answer?
AD,
Yes. Another one?
BD.
Yes, correct. Yes. So for this case, the R is only 2. We do have only 2 R, okay? Because the point at the force, we have only one, which is D. This one, we cannot calculate because we don't have any information on that, okay? So R here can be 2. The first one is don't know. The first one is don't know. The second R is really don't know. Okay. So the R is 2. R is 2. Okay. From A to D here. R A D. Okay. Or here B to D. R B D. Okay. So in this case, we do have 2 R only. 2 available R. Then we can choose either one later on. Okay. So you have to determine R first. So this is the way that I always use. You have to determine R. Okay, let's say we want to determine RBD first. So how to determine RBD using trigonometry lah, of course. Okay. So how to determine RBD? Anyone?
Square root of 0.25 square minus 0.15 square.
Apa ni? Ahsan eh? Again Ahsan, can you repeat?
Square root of 0.25 square minus 0.15 square.
0. Sorry, 0 point?
One second. Sorry, I got confused. Just a second.
Okay. Okay. Ada student? Li Jiaying, yeah. Any idea on how to determine the RBD? This is mathematics only, not really static. Mathematics. This one is mathematics.
Oh, natot.
Don't know. Tak dengar lah.
Hold on, natot.
Oh, hold on. Okay, alright. Okay, Farah Amira, how to determine RB? This is mathematics. Mathematics. RBD.
Using Pythagoras theorem?
Yes. So then Pythagoras theorem, yes. Where is the triangle?
I think first we need to find RAD, then we can find RBD.
Oh, really? So how to find RAD? Okay, forget about RAD first. My question is RBD. Don't get confused yet. So let's focus RBD first. Without having RAD, we can get RBD actually.
Doctor, is it we need to find the angle OBC?
OBC, yes, correct. The first thing is you have to find the angle, and later on the angle will be useful to determine the x component of RBD. Okay, let me explain. So the first triangle that you have to solve, you have to use this triangle. This triangle. This is mathematics, not really static. Okay, why we choose this triangle? Because we do have information. Okay, the length, the hypotenuse, 0.35. Oops. And this length BO is 0.15. Okay, so the angle that the student said just now, this angle theta. Okay, all right. And then I give you an idea first why we have to determine the theta, because later on the theta will be useful to determine this line. Okay, this line. This line. Okay, this line. Okay, this line memang perpendicular lah. Okay, why we have to use this line? Okay, let's say I put this point is E. Why we have to determine this ED? Because RAB can be written like this. Okay, RBD can be written like this. Oops. BE. Oops. Plus ish. Kenapa ni? Ish. Macam suruh habis kelas je. La ilaha illallah. Wait what happened to my laptop? Sorry. Let me change another color, maybe something different. RBE plus RED. Okay. RED. Okay. 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 Okay ke tak? Are you okay or not? Do you get the idea? Do you get the idea? Guys, do you get the idea on what to do?
Yes, doctor.
Okay. So the first thing is that you have to find theta lah. Theta. Okay, theta. So can you get the theta from here using the big triangle there?
Is it 4.8?
Sorry, 4 point.
For theta COC.
CBO, is it?
CBO, yes. The theta is, I got 64.89.
64.89. 89. Okay, everyone please check the answer. Do you get the same answer or not?
Doctor, I get 64.62.
Wait,
Yeah, same, me too. 64.623.
wait, how much? 64? Sorry, how much?
64.623. 64.623.
Okay. So if you calculate using cosine rule, okay, cos rule, okay, trigonometry, you will get cos theta equal to BO. BO means 0.15. And the hypotenuse is 0.35. So you will get theta straight away. So how much? Let me check. Yeah, the answer is 64.62. Okay, degrees. Okay, So the answer is 64.62 for the theta. Okay. So from here, from this theta, you can get ED and also BE. Okay. You can get ED and also BE. So using the small triangle there, okay, this triangle, small triangle, okay, let's say put it in two dimension lah. This is point B, this is point E, oops, and this is point D, and the theta is here. Okay, so we can get the value of EB and ED. DB is given, BD is given 0.25. Okay, so you can get the EB and ED. Can someone tell me what is the value for EB and ED?
Doctor, for ED, I get 0.226.
0.226. ED?
Zero point 107.
Okay, can someone else check the answer? Do you get the same answer?
Same.
Same, eh? Same, eh? Confirm, yeah?
No, doctor, the value is
Terbalik.
Oh, terbalik. Opposite. Terbalik, eh? Let me erase first. Okay, EB 0.1.
107.
ED 0.226.
226.
Okay. Okay, can someone else check the answer? Check first before I proceed. Do you get the same answer, everyone?
Yes, doctor.
Okay, great. So yes, then I can proceed. So from here, from this triangle, we can get RBD actually. RBD is equal to RBE. Okay, BE should be negative lah. Negative 0. Oops, what happened? What happened? Happened. Okay, give me some time. Negative 0.107, and the direction should be IJK. Okay. RED is the magnitude is positive plus 0.226, and the direction is S, which is I. Okay, this is your RBD. Okay, this is your RBD. And I believe that if you choose RBD, RBD is the simplest one compared to RAD. Do you know why?
Because only two exist.
It's the shortest distance.
Little exist meaning that little component lah, is it?
Yes, doctor.
Yes, correct. So if you can imagine, if you can look at this figure, RBD and RAD, we can see that RBD is the simplest R, because RBD is only have two components, okay, I and K components. But for RAD, we do have three components, okay, three components. So to reduce, to avoid more time, okay, we can use straight away RBD instead of calculating RAD, because we know that RAD we give three components, okay, three components. So we use RBD straight away to get the moment. okay, to get the moment. And of course, the moment about an axis, okay, using this equation, okay, lambda axis dot f. Oops. Give me 1 second. Yeah. So let me erase this everything. Okay. Okay, let's continue. So once you have BD, what is the next step? What is the next step? Guys, what is the next step?
Doctor, we find the lambda axis.
Yes, of course. We can find the lambda axis, and then we can find the f. Okay. Let's say you said that you want to find lambda axis first. Then we have to find lambda axis. Okay. Using the coordinate method, you can get the lambda axis. Okay. So what is the dx? Dx from B to A. Come on, guys. We do have more 10 minutes left. Dx. What is the value for dx from B to A?
So the dx is 0.
Yes, correct. Dx is 0. Dy?
dy is negative 0.3.
Negative.
Positive 0.3.
Yeah. From B to A, From B to A, dz?
dz is negative 0.15.
Yes, correct. Okay, this is your dx, dy, and dz. How about d? How about d? How much?
Doctor, d is 0.335.
0.335. Okay, everyone, please check the answer. Do you get the same answer?
Yes, doctor.
Yeah, same.
Okay, great. So you have to substitute into the equation. So we do have two component only. 0.335. This one is j. Okay, and then minus 0.15 over 0.335k. And can you simplify the answer for me? Can someone simplify the answer?
Doctor, I get 0.896J
Okay.
minus 0.448.
Okay. So everyone, please check the answer. This is your lambda BA. Yeah.
Same 0.8955 and negative 0.447.
Okay, great. So let me copy this one first. Okay lah. Wait, yeah. Okay, what's next? What next? What is the next step we have to do?
Find endpoint.
Find what?
Convert the F into IJK component.
Yes, correct. So you have to find F in terms of IJK form lah. So okay, what is the value for F? This one is straightforward. In terms of IJK form. Straightforward, no need to use a rectangular lah, a second angle method lah, coordinate method lah. No need to use that.
150K.
The direction? Then K. Not K.
Doctor, negative 150 J.
Yes, correct. The F is negative 150 J Newton. Okay. So there is only one component because the F is along y-axis. Okay. So then you have all information. Lambda, you got it. F, you got it. Okay. So substitute into the equation, you will get the moment. Okay. So lambda BE cross with F. Dot with F. So lambda BA, where is lambda BA 0.89, 0.896 J. Okay. 448. Okay. Dot with where is the F G. Okay. So you make it like this, then you will get the final answer. Okay. Can you check the answer? Is it similar like given in the slide?
So how about R?
Doctor, shouldn't
Yeah.
Answer F tu kena cross product dengan RBD ke?
Sorry?
Kan M axis equal to lambda axis dot product endpoint. Kita untuk endpoint tu F darab F cross product dengan R dengan distance yang kita dapat tadi.
Sorry I missed one step Yalah, correct lah. I missed one step. So we have to find the moment about a point first lah, right?
Yes, doctor.
Isn't it? So let me repeat. Thank you. Siapa ni Ikmal
Ya, doctor.
Okay, thank you for reminding me. So you have to find the moment first. Okay, the moment about a point. R cross F. So R that we choose just now. Where is R? This R 0.107. Apa ni? J ke I ke? K 226. Okay. Cross with F. Okay. Can someone tell me the answer?
Doctor, I get negative 16.07 I.
16.07
I.
Okay.
Minus 33.88 K.
Okay. So everyone please check this answer. Is it same? moment about point B, RBD. Okay, RBD. ABC. Okay. Moment about point B, RBD. Please everyone check the answer while I'm writing the solution. So we do have AB, BE equal to lambda BE dot MB. Guys, do you get same answer for MB? Okay, Wong Kin Tong, did you get the final answer? Is it same as shown in the slide?
Doctor, for the final answer, I get 15.17 Newton meter.
15?
Yes.
15?
15.17.
Okay. How about the rest? Do you get the same answer? Lambda BE, 896. G 0.488 G. Dot with MB. So we do have one component lah. Negative. Tak muat lah nak tulis. So I delete this one lah. Okay, so the the MB negative 16.07 I minus 33.88 K, and you will get the answer. Okay, so everyone, do you got the answer? It should be K only, 0.488, 33.88. Okay. Why I got the same, the different answer with King, with you, Wong Kin Tong.
Doctor, the lambda BA, it should be negative 0.448, not 488.
Oh, okay. Sorry. This one issue 4 lah. Okay. 4. Okay, same answer like Wong Kin Tong. This answer. Do you get the answer, guys? Dapat tak? Ayush Syahada, dapat?
Dapat
The same answer. But
Okay. Ahsan, do you get? Hussein, Ali Hussein, do you get the answer?
No, doctor, I didn't get the same answer.
Oh, okay. What is your answer?
I got 37.5 for some reason.
Wait, where is the wrong thing?
final calculations.
MBA.
Yeah.
How about lambda BA, MB? Is it same?
Yes. Yes.
How come different? Lambda and MBA is same. Should be same answer lah for MBA. I mean, the answer is 15.1.
You see, I found the result for only MB. I didn't do lambda BA.
Siti Nur Balkis, dapat tak?
No, doctor.
No. Which one? Which one? The final answer.
Yes.
How about lambda BA and MB? Do you get the same answer?
That one I got the same answer, but the final one.
The final one is only K component, dot product. You only have to multiply this thing only. The rest you can ignore because this one is dot product. .448 times with 3.88, you will get 15.17. This is dot product. So the rest I and J you have to ignore because the dot product between I and J will be not same lah. JI, JK, KI. Boleh Siti Nur Balkis.
Okay, dapat doctor.
Dapat. Wang Jiayi. You get the answer?
No, doctor.
Okay. Nah, no. Which one you didn't get? Okay, before I end the class, the time now is 10 AM. Just want to remind you about the final answer. Okay, some cases the answer will be not really similar from the books. Okay, because if you can see, if you can imagine, if you can look at again the solution that we have right now. So this one, for example, the theta. Maybe some of you use one decimal places. Maybe 2 decimal places, maybe 3 decimal places, maybe 4 decimal places. So those decimal places will affect the final answer. Okay. In this case, we use 2 decimal places. Okay. Maybe the answer given from the lecture note using 1 decimal place. For example, maybe use 3 decimal place. That's why we get this not really 100% similar, but within the error lah. So in the final answer in the test, let's say the answer is within the range. So I will accept the answer because of this issue, because of the angle issue. Okay, maybe some student use only 64 degree. Okay, and this one will affect the final answer. So normally I will put a range. Let's say the answer given 14.52 Newton meter. I will put plus minus maybe 2 Newton meter. So if the student get the answer within this range, then I will accept it. Okay, and the solution that you write in this paper, if the solution is correct, then I will accept the answer. Okay.
Doctor, may I ask for the final answer? Normally, how many decimal place we should?
Okay, normally for me, I suggest you to put 2 decimal places. Only 2 lah.
Okay, doctor.
Okay. Cannot more than that. If you want to put 1 decimal place, then okay as well. But I suggest to put 2 lah. To put 2. Okay. There is no fixed one, but it is depend on you. Okay, depend on you. Normally for me, I will put 2 decimal places. Okay, I think that's all for today. I believe that you have class after this at 11. Ada kelas ke? Ada kelas? Tak ada eh?
Yeah, we
Do you have?
already started.
Oh, already started. Okay, okay, all right. Okay, thank you so very much. I
Thank you.
think I have to share to you the test, the sample test from the previous batches. So I will upload in the e-learning, then I will inform to you later. Okay. So that's it for today. Thank you so very much. See you next week. And of course, test 1.
Thank you, doctor.
Thank you,
Thank you,
doctor.
doctor. Thank you, doctor.
Okay, okay.
Thank you, doctor.